What's going on, Algebros? This is Mr. C here. In this video, we're going to get some practice with translating verbal descriptions of transformations into function format. Let's dive right in. First example here, write the function whose graph is the graph of the square root of x, but is vertically stretched by a factor of 4, reflected about the x-axis, and shifted left by 8 units. All right, so what I'm going to do to start this out is draw a square root symbol, and I'm going to make it a little bit longer, and you'll see why when we talk about the 8 units shifted to the left that this graph has to represent. I'll put x in there, and going from left to right, the first description of a transformation is vertically stretched by a factor of 4. So in order for the graph to be vertically stretched, we need an a value, or value in front of the square root, that's larger than 1, and they provide us with a value of a that's larger than 1, and that would be 4. Now if it said vertically compressed, we would have to figure out a way of rewriting the 4 to where we'd get a shrink of the graph, or a compression, and that's actually something we'll do in the next example. But for now, if our graph needs to be vertically stretched, we're going to need to put this 4 in front of the square root symbol. The next verbal transformation is a reflection about the x-axis. And you may remember my trick to helping us out with that. Any reflection involves negatives, either in front of the library function or inside of it in front of x. This is a situation where we'd want to put a negative in front of the function, and my cheesy trick for that is that the negative is on the exterior. How do you like that? Exterior, x for x-axis. So long story short, we'll place a negative in front of the 4, and both those are in front of our square root. So the combination of negative 4 allows our graph to get vertically stretched as well as reflected about the x-axis. Now, shifted left by 8 units. The fact that it says left here means that there's a horizontal shift. And remember, with horizontal shift, you want to think opposite or think backwards. If we want this to move left by 8 units, then our natural inclination might be to have a -8 somewhere in the mix here. But since it's a horizontal shift, we're going to want to use +8 instead. So where do we insert this? Well, keep in mind that horizontal shifts always are represented by addition or subtraction directly to x, i.e. inside of the grouping symbols. And our grouping symbols here is the square root. So what I'm going to do inside the square root, directly after x, is write +8. And there are no other transformations to incorporate into our equation. Therefore, this is our answer, -4 times the square root of x plus 8. Let's try this again with the next example. Write the function whose graph is the graph of y equals the absolute value x, but is vertically compressed by a factor of 3. There's our first transformation. Shifted right by 5 units and shifted down by 6 units, like a G unit. All right, so I'm going to start out with the absolute values. I'll place x in there, and I'll leave a little bit of a gap just in case we need to accommodate a horizontal shift, which, as you might guess, we will have to. And we'll start here. So going from left to right, reading the problem again, vertically compressed by a factor of 3. Now you got to be careful with that. This is speaking to a particular value of a, but if we left a as just ordinary 3, this would actually cause our graph to stretch. We want our graph to compress, or in other words, be a little wider. Placing the 3 in this way would actually make our graph a little more narrow. So the fix to that is just to do the reciprocal of this number. That is, a should be 1/3. Okay, and I'm going to place that in front of the absolute value symbols. One nerd. And we'll move on to the next transformation, shifted right by 5 units. So the fact that it says the word right here means that this is a horizontal shift we should consider. Got to make sure to remember the F in my right shift. And here we got to think backwards. So to the right would mean that we would have to place 5 in the mix as -5. Now again, horizontal shifts take place inside of the grouping symbols. And our grouping symbols here would be the absolute value symbols. So what I'll do is write it as x minus 5. Okay, again, think opposite. And then down by 6 units is speaking to a vertical shift. The fact that it says down means exactly that. It's a vertical shift. Now, remember, vertical shifts happen at the tail end of our function's equation. And we can think normal. So if we consider the word down, you might better associate it with a minus sign, and that's actually okay to do with vertical shifts. All right, a minus sign will make your graph go down, whereas a plus sign will make it go up. And keep in mind that we place this at the tail end of the function, i.e., at the very end of this, we're going to write -6. And that would be our answer. All right, folks. Well, I hope you found these 2 examples transforming. If not, and you got some questions regarding any of my work here, feel free to let me know. Otherwise, thanks for watching, and I'll see you next time. Take it easy, Algebros.